Hi there, I hope you're doing well. Today I want to take a brief moment just to talk to you about the next few months of footage, of videos that I'm going to launch on this specific channel. So in my collaboration with Building Point SA, we're looking at some hardware for 3D scanning. There's some really exciting tech that's coming out. I've been given the privilege of using the technology over the last month, and we've been able to scan some properties, and there is so much information, there's so much exciting workflow techniques that I can share with you that I just wanted to give you a little teaser of what that can be for your workflow. So if you haven't subscribed to the channel, please like and subscribe here. And then you'll get a notification, of course, for the next few videos that will describe the workflow of using a 3D scanner for whether it's a site visit, gray boxing, white boxing, whatever environment you have around you. If you need to have that environment detailed, available for you in a digital format so that you don't have to go back and forth to site to take measurements, then these are those kind of videos, and this is the hardware that you need for that. Now, today's video, I want to focus with you on techniques where you have a workflow without perhaps the necessary data or the technology to scan a space. And I want to use some techniques and demonstrate them to you in this workflow video where you might not be able to go to site. Sometimes you might be able to drive or fly somewhere. In the case that you can't, there might be satellite footage, there might be a 3D reference model, there might be a sketch from a client, there might be an as-built plan. So if you're not able to go to a specific location up front, but you do want to do some kind of site study, or you want to do some preliminary work in SketchUp, then this is one of those techniques. I hope you enjoyed this video. If you've got any questions, please leave them in the comments below. For any other further information, feel free to reach out to me on LinkedIn, and I hope you enjoyed this video. Okay, so here is the workflow demonstration of getting as much detail as you can about a site where you want to work on a project, where you haven't visited the site in person. So I came across a LinkedIn post by Katay Kim. Katay heads up a company called Foveate. Foveate is a browser presentation tool. And so when you use Foveate, you can basically in a NVIDIA Omniverse mini version, you can pull all kinds of assets from other 3D technology into Foveate and then make it a presentable browser environment. So a really great way to present any of your 3D files, any of your 3D layouts. And the great thing about Katay is he comes from a experiential architectural background. So he understands a lot of the different use cases, the different needs of the different professions that all come together around these presentations. So go check out Foveate, check out Katay's latest activity on LinkedIn and elsewhere. He's got a very interesting profile and is someone with a lot of insight to follow. So without further ado, what I saw from him, which really inspired me, was about 2 months ago, he shared a post. And this post, for context, is of a building in New York City. It's, as you can see on the photo here, it's classic Louis Vuitton box packaging or their travel cases. And what they've done is the building where Louis Vuitton is hosted on Fifth Avenue, they are going to renovate this building. So in an effort to renovate the building, they're going to put up what they call in South Africa hoarding. Right? So they're going to put up a perimeter, and that perimeter is going to make sure that they can do the construction work without there being any danger to the public. And so one clever designer thought, look, hoarding doesn't have to be an ugly thing. Let's make the hoarding look exactly like our
our travel cases. So this is, on one hand, perhaps a bit of a publicity stunt. It is a reminder of one of the products that they sell, and it is perhaps to some a far prettier way to encase your building instead of in construction tape and secure netting for any falling debris. They encase the building, so to say. So apart from this this beautiful scaffolding, we're just going to take a look at what would it look like if you had to model this. So what if in SketchUp you had a reference for this, the size of the building perhaps, and you would model this environment, you would model this Louis Vuitton travel case around the building. And could you sort of end up with a construction drawing that gave you perhaps a rough estimate of what would be required material-wise? So I'm not going to make a very long workflow video describing to you every single step that I took to get this right or to make this, but I'm going to mention every piece of software, every plugin, and every step here in the description. So if you want to highlight a very specific step, then feel free to go through all of the links in the description. So first of all, let's look at not so much the building, but let's look at the location. So I'm just going to search this image with Google Lens and then say, let's say that this is literally the thing I'm searching for. And then perhaps there's an article that we can see where someone describes the, where someone describes this. The AI, Google's AI is clearly helping us. The installation is a temporary facade during the renovations. Yes, people are commenting on it like that. The concept is more of an artistic installation advertisement. Okay, let's just click on one of these links to see if there's a bit of a narrative here. New building trend. No, that's not what we're looking for. Okay, let's look at Levi Trunk NYC scaffolding. Okay, here's an article on the zine. All right, so there's quite a lot of detail here. And the first thing that we know is the location now. So Louis Vuitton covers its flagship at East 57 and 5th Avenue. So then let's go to maps. And let's go to 5th Avenue and East 57. East 57, Louis Vuitton, NYC. And let's see if we can find a location. The location is here. We can look at this map in 3D. So let's turn around a bit. Okay, so this is the area where the building is positioned, and it says that the store is here. But if I remember correctly from the photo that we just looked at on the zine and on LinkedIn, this Louis Vuitton, there's even a stamp, Louis Vuitton trunk is here. You can see the basic scaffolding or the basic glazing that was going up to set this all up was already being installed. These photos perhaps date from mid-2024, just before the trunk was erected. So now we have this location. Now, one thing we can do, and I'll take you straight to the export of this area. One thing we can do is we can use a software called Blender, which perhaps you're familiar with. And what we can do in Blender is, you can see here, I'm not that familiar with Blender's user interface, let alone all the tools that it has. But in Blender, there is a plugin, an add-on called Blossom, which you can see opens here on the right-hand side. And in Blossom, what you can do is you can select an area. So by clicking on select, it will take us to a website that looks quite similar to Google Maps. And then by typing in the address, by basically searching for East 57 and the specific Louis Vuitton building, we can find that section of New York City. And so when we then paste those coordinates into the Blender plugin Blossom, then we can download into Blender this 3D model of Google Earth's 3D data. So I'm not saying that this is millimeter or inches accurate. This is a wonderful 3D photogrammetry satellite combination of photos into a 3D shape. Excuse me. I think I swallowed a fly while we were starting this video just now. So we've got the 3D data now in Blender. And this is where we'll start. If we export this out of Blender into SketchUp, where we can start manipulating it and use our native SketchUp tools to create the trunking, then what we'll do is we'll simply replace the materials to make them export ready. That makes sure that the texture is baked into the 3D mesh. And then if we go to File and Export, we can export a range of files that SketchUp can import. But the file that I'm most confident with and most happy with when it comes to file size is a GLB file. So ever since SketchUp updated its graphics engine to be more aligned with the NVIDIA Omniverse work frame, you can now import GLB and GLTF files, which is great because those 3D meshes are relatively low in file size and it preserves all the texture data. So I'm going to do away with Blender for now. We've got our file, our 3D environment, and then you'll see in SketchUp here I've got a 360 photo of that specific site in New York, and you can see that the scaffolding on this specific 3D photo is being erected. There's the street sign with East 57, and then looking towards Central Park, we're of course on 5th Avenue, and we can look in the complete opposite way to see the rest of that part of New York City. So this is a 360 photo in SketchUp. And what we've done is under the Environment tab, we have clicked on the plus button and we have imported a 360 photo. Now, how do you import a 360 photo, you say? Okay. When you're on Google Maps, you can, of course, step into the 3D bubble, the Google Street View card. Now, to export the 360 photo, you can use a little app called Street View Download 360. It's available on Mac and Windows. Again, I'll leave you a link in the description. And apart from me being able to download and update, this gives you quite a wonderful tool set. So go to Google Street View, make sure that once you're on Google at that specific location, you enter Street View, you go stand, let's say, at the crossroads of the two streets. It gives you that overview. So this is the street. Then you can copy the URL, paste the URL back into Street View Download 360, and then choose any of the resolutions that are available for that. Let's stick to a single panorama, download the panorama, and then as far as I know, it either saves it automatically to a specific file type or it saves it automatically as an HDR. Anyway, if you've got any photo editing software, you can then of course save the photo or resave the photo as an HDR or an EXR file, which SketchUp then recognizes as a 360 file. So the nice thing is I've got this 360 environment, and the sun position, as you can see here, can be manually manipulated. So I've selected the sun to be in relation to where the photo, the time of day on the photo. And so my shadows in SketchUp now align correctly with this afternoon shot. Okay, then I've clicked on File, and I've suggested that I want to import, in this case from my desktop, that specific GLB file from E57 Street. So I've got my Street View image and my GLB file, which I exported out of Blender. And now what I'll do is I'll just zoom out a little bit. You'll see my 360-degree photo doesn't change in size, but the 3D model that I imported from Blender does change in size. And so what I can do is I can now zoom in to the roughly specific location I got out of Google Street View. And I can best line up my camera to the viewpoint that the Google Street View car had, right? So now what I'm looking at, if I now use the eye tool in SketchUp, the look around tool, now while I'm looking around, the sky that I see is the 360 photo, and my background, so the trees and the buildings in the background, that is the 360 photo. But the buildings up close to me, they are the 360, or sorry, not the 360, they are the 3D model out of Blender. So out of Google, I got a 360-degree photo, and I got a small 3D model of the buildings. Now, of course, the detail that we see here of the cars and the trees, the mesh of that detail is a little bit broken, right? That mesh is very inaccurate. If I now zoom out a little bit and I look at the overall shape of the buildings, then the scale of the data, the resolution of the data appears much better to the eye, right? So this this holistic bird's eye overview of the street and the surrounding buildings on E57 and Fifth Avenue, this data looks great from this angle. If I zoom in, it gets a little bit low resolution. So you wouldn't really want to be this up close. But for the sake of this exercise, when we want to design these trunks around the facade of the building, we now have the rough sizes of the building. So let me create a few scenes so that we can work in this model a little bit easier. So I'm going to create a scene here where we have basically a top-down view of our 3D environment. I'm going to create a scene where I'm standing. So I'm going to use the position camera tool. I'm going to look towards the building. I'm currently at an eye height of pretty much 0. So I'm going to go to 1.6 meters or roughly 5 feet. And then you can see I'm standing just above the ground and I can look at the building. So from this angle, although I can't see the whole building, I'm going to leave my cursor here, my viewpoint, and create an additional scene. And then while I'm editing the 3D environment, I don't need to see the whole data set and I don't need to see my environment. So I'm going to say, stop using the environment as a sky dome and stop using the environment for reflections. And then you can see now the 3D photo is gone, and all I'm left with is this big 3D file of the street. And I'm gonna save my third scene here. Just make sure that my camera stays in perspective and my field of view, I can leave that at 50 degrees. Okay, so this will be scene 3. So scene 1, We'll change the camera to parallel projection. Yeah, and we'll put it like, we still want to look at our building, so let's position it like something like so. We'll rename that seam after we update it. We'll rename it isometric, or ISO for short. Then we'll go to scene 2, which is sort of our render scene. Yep, that's scene 2. This is the viewport, or the view from a person standing on the street. So we will call this view street level. And then in scene 3, we zoom out again a little bit and we don't see the environment. Now you can see it takes my computer a little bit of time to switch between seeing the 360 photo and seeing only the 3D model. So what I'm going to do is I'm going to my styles and I'm going to make sure that I am using a default style shaded with textures, and make sure that I don't have my shadows on, and make sure that I don't have my ambient occlusion on. And then I'm gonna update scene 3 and rename it to draft. So in the draft environment, we can really quickly design. I specifically chose that shaded with textures style and made sure that my shadows were off so that I can navigate the model really quickly. At this point, I don't want my computer to be calculating shadow sizes, lines, and fall off. I want my computer to focus on the geometry that I'm manipulating to design the trunking. And when I switch back to the street level view, where I sort of want my final render view, there I will then turn all the fancy features back on. So this is pretty helpful for now. Now this mesh, this 3D data, is of course quite a complex mesh. And if I looked at the properties of it, it will probably be quite a large component or quite a large asset. And I could save out that component to a device, or to Trimble Connect, or to the 3D warehouse, just so that I can see what this thing is made up of. And sometimes it's helpful to save components out so that you can delete them out of your model and then reload them at a later stage, just so that you don't have to use all your computer power to render complex geometry. But for now, the computer seems to be happy to work in such a large model. And what we're going to do is we're just going to redraw the building in a sort of simpler shape. So I'm going to draw a rectangle. And now perhaps the rectangle that I want to draw is not aligned to my axes, because I have aligned the model in a previous session before I started recording this video. I've aligned the model, of course, to the 360-degree view photo. So my axes are aligned to the photo view, not so much the axes aligned to the street direction. So I can either turn my building, or I can draw a box. So that's what I'm going to do first. I'm going to draw a box, and I'm going to extrude that box. Then I'm going to make that box a group. And then what I will do is I'll move that box to the point where it inferences with the corner of the building. And then I'll use the rotate tool to line the building as best as possible. Now, if I follow the direction of the software and try to snap it, it gives me an angle of about 28.9 degrees. Okay, so I'm just going to remember that number so that I can turn it back later on. And then what I'll do is I'll use the scale tool, and as much as I can perhaps snap back to the geometry, at this point I'm just sort of eyeballing the sizes. I don't think, or maybe there was trunking at the back of the building. Maybe it's not just the front and the side. And then once I've got the back here, then this gives me the rough dimensions of the building. Now the building is of course not completely a rectangular box. It tapers off towards the top. It steps back, which is according to some legislation within New York, where you're not allowed to build the front facade all the way up. You need the building to step back. So just hiding this box, we can see it steps back 1, 2, 3, 4, 5, 6, 7 times roughly. We can draw all these steps in to create a true replica of the building. We could do something like the offset tool, and then we could use the push-pull tool to pull this down back to a level where we understand what's going on. We could also say, no, this is box 1. So I'm going to make a group out with a group inside a group. Then I'm going to scale this down to the first point where the building steps back. And that didn't snap as intended. Let's try that again. Okay, that snapped relatively better. And then what I'll do is I'll duplicate my box. And now in smaller increments, we'll create these steps up. So perhaps first I should create a replicas of the original box, original cube. Then align those at the sort of individual level to the specific height. And then once they align to the height, I can manipulate the width and the depth. And again, if I create multiple groups, it's much easier to manipulate the groups further down the line than to manipulate the what am I saying? It's much easier to manipulate each group individually regarding its geometry. And so what I'm doing is I'm starting to scale each box. And what I'm using is, if I read at the bottom of my screen, it says I can press Ctrl to toggle scale about center, and I can press Shift to toggle a uniform scale. So if I press Shift, it uniformly scales. If I press Ctrl, it scales around the center. So I'm pressing that and I'm trying to align it. And you can see, because it scales uniformly, it has now also scaled in the vertical direction. So I can scale it back, of course, in the vertical direction, but then I need to turn off the scale around, or scale proportionately. So I can scale it side by side. So I do right first, then left, then the front, then the back. And this is a little bit of a tedious process. So to speed this up a little bit, I will say yes, toggle around the center. Computer is having a bit of a think about that idea. Okay, toggle around the center, and then that first step back. It's not a very big step, but significant in its own way. That we will let step like that. Okay, now let me just use the 3D mouse to get out of this building. Now within my group, I have a rough replica of the step back of the top of the building, and I still have my 3D model of this section of New York, this Google 3D tile, as Google calls it. Now what I will do is I'll go to my tags and I'll create a new tag. I'll call it Google Tiles, and then messing model, and I will select this group, and then under the entity info I will assign it Google Tiles, and then I can hide that tag so that all I'm left with is my messing model. And my messing model I have not assigned to the right tag. Now I have, and I can also turn that tag on and off. All right. So like I said earlier, let's make a quick component and then align the component for ease of use back to the central axis. And then this is the 28.9 degrees that we have to turn back. So I'm moving this slightly off the central axis, or maybe I should just lock it in to our origin point and then hide my second component quickly. So now I've got a little bit of a working model in my draft environment, and we can go back to our news article on the zine where we saw quite a few decent photos of the trunks. And then we can get a bit of a reference towards the stepping back. We can get a little bit of a reference of the texture that is used, the handles, the locks, the clips, and we can get, using this photo, at least for the first two trunks, we can get a decent reference to where, on what height line, in relation to the next building, does the height of the box stop and the next box start. So if we find a texture of Louis Vuitton's motif, this little repeatable pattern, then we can perhaps draw these trunks with a little bit or as much detail as we want and replicate or mimic this environment. There's some beautiful close-up photos actually in this news article. So there is space here to go into the 3D warehouse. We could actually take a screenshot even of this detail and then drag it into the 3D warehouse search bar, which uses photographs as well as a search tool. So let me drag my my Google Chrome to the side here and make it a little bit bigger. Then let me open up the 3D warehouse. And then by dragging this photo into the 3D warehouse search, we can maybe find a Louis Vuitton trunk. Well, there are some buildings that have been drawn before. So we might actually find some buildings that are relevant to this street corner. But that's not what we came for. So let's zoom in on the trunk and then drag the trunk photo in so that the search engine is not getting confused by the other buildings. There we go. Here is an iconic 8-watch case. And then there are some other trunks. The brown texture of the brown pattern. I mean, there are sufficient trunks here, right? So the brown texture is quite a good texture. This is gray, black with gray and a gold band. Or maybe it's not as gray as we think. It could also be the photograph. Here it looks a little bit browner. Maybe this first case is the right kind of case. Although this case here does have the gold band running across the side. So the steamer trunk at 300 kilobytes also has all the latches, and it does appear that there are these latches and clips. So let's start here. The problem I have with this is I don't have high hopes for a 300 kilobyte file. This might be a 2D texture on the box. I'm just waiting for the model to show. There it is. It is of course a lot smaller than. Yeah, so see, unfortunately, the trunk is modeled out into the shape of a geometric box, but the detail is not modeled. And that is, I suppose, what you get from such a small file size. a little bit confused why I didn't reopen my last search. However, we can repeat our search in the hope that it gives us the same results. Not too bad. So the 300 kilobyte file is a bit too small. Here's a 1.2 kilobyte file. Here's a 1.8. So we're really looking for a Louis Vuitton trunk that has enough detail in it. Let's do a word search. Louis Vuitton trunk. And mind my spelling. Vuitton is with 2 T's. Nope. Maybe LV trunk. Maybe just the word trunk. Yeah, see, the word trunk does give us quite a few good references. Now the only thing that I want is to see if we can avoid having to download the texture. I just want to see if we can use a SketchUp texture straight away. That might save us a little bit of time. Okay, so here is a fashion trunk. This is a 1.8 megabyte file with quite a few polygons. This might just have the information that we need. And let's see how it loads the model in. Okay, there we go. All right, so here is both the Louis Vuitton texture. The handle and the clips are perhaps not identical to what we were looking for, but this gives us a much better starting point. Let's delete that previous unit. Let's explode this. It seems like it's holding on to some other geometry. So now we're left with the singular box, the singular trunk. Then for reference sake, we're gonna just scale this trunk up without remodeling or changing it up. And we've got a sort of lower trunk and then what looks like a taller trunk. And the lid here looks quite significant. So let's stack these first two in relation to the building next to us. So we're gonna position this on the corner. Oh, and this does reveal that I've broken it a little bit. Let's regroup that and then make a component. So the reason why this is bigger than my object, when I turn hidden geometry on or view hidden objects, and I go into this specific file, and I just unhide all the objects, can I see why I can't seem to quickly figure out what is the geometry that is hidden from me. But for now, what we will do is we can do two things. We can explode everything so that we only grab the right geometry, and then it will hopefully give us a good exterior to manipulate. So let's explode this, and let's explode that. You can see it's now going to take a little bit of time. Is there more to explode? No, that's pretty much it. If we now make a group selection and make it a group, it still finds some geometry that's missing, or that is left outside of a specific environment. Can we explode it again? No, this is all exploded. Let's make it a group. Okay, that seems to be better. It doesn't have anything to do with my Google tiles, right? No. They are a different entity altogether. Okay, so this has not selected the outlying geometry that is not in the right space. Let's go to the corner here. And let's leave this unit for now because it does have the components segmented properly. Let's scale this. Yeah, let's scale this trunk. And let's scale it as best as possible to just outside the building, because we do expect that there is some scaffolding between the building and the trunk exterior. But for our visual, I'm not going to try and manipulate the box too much. And so that should give us some space. Now with distorting the box a little bit, we're going to turn the Google tile model back on. And then in relation to this first building that is next to us, we can hopefully see in the photo again how these trunks relate. So that first break of the windows, the two colors on this building, show the two colors here. So that's where the bottom trunk sits. And then the top trunk goes straight to the first setback of that skyscraper. Hide the website, hide the tile. So this model, of course, was a replica of the actual model on the right axis. So I'm going to copy the trunk or cut the trunk out. I'm going to go into my component and then paste the trunk in place. Okay, now it is in place. I can simply just delete the previous or the right aligned model and then be left with my 20.89 degree model, and then bring this up to that first break in the window. Let's set about here. Then let's duplicate the trunk and position it there, which the photo of course is taken from an angle, so it's a little bit of a push of me to say, oh, the top of the trunk stops with the top of the first step back. In this photo, that seems to be taken from a better elevation, perhaps using a drone or standing in the building opposite street corner. We can see it actually breaks before the setback. So it breaks on this line, which seems that it is two equal height boxes, two equal height trunks. And the nice thing is that that second trunk, it seems to cover the first setback, the second setback, and the third setback, right up to this indentation on the last setback. So perhaps the scaffolding that was required, the stepbacks that were created, were of course there to cover part of the remainder of the building, but not too much that the scaffolding would go all the way up. So now let's manipulate the third box and let's reduce it in size. So I'm going to scale from the top and just press Shift to make sure that it manipulates in all directions at the same time. And it is 1, 2, 3. So that first box is quite a lot shorter. And I'm going to turn Shift off so that I can bring it back. Now, of course, if I manipulate it too much, so back up to this level, then my handles get terribly squashed. So what I'm going to do is I'm going to go into my group. Now, I exploded all this geometry. So like I said, that's often not a wise thing to do if you want to manipulate individual items, because to make a selection of this now is horrendous. However, with everything broken, I can make a group selection of all the bottom geometry. So I can actually manipulate the bottom, and I'll bring that up 40 meters or so. That is way too much. I'll bring that up. Oh, bring it up 4 meters. Yeah, that's better. And then I can see that these 3 studs are manipulated now into the handle. That's a little bit weird. Now, of course, I can't select this because then I'll be destroying the handle. So let me go back a step, get rid of this stud, and select the bottom of the box again, and then move that up the initial idea of 4 meters. And then I can still manipulate my trunk using the scale tool. So let me go down and then manipulate it using the scale tool. So I'm going to manipulate it till a scale of, let's say, 0.6. All right. That seems to be more in line with the photograph. So 1, 2, 3. 1, 2, 3 handles. You can see actually the orientation of the handles goes from the front to the side of the building here. So the visual is dressed slightly different. I don't think we're going to get into that detail here today, but it's a nice thing to know or to note. And then that second box and that third box, 1, 2, 3, they go slightly smaller, but not that much smaller. So let's go up to the straps. 1. Let's decrease the height again just a tiny bit. Each time I turn on hidden geometry, so I can actually see all my scale handles. So that's 2, and then that would be 3. That does cover the whole building. We'll make that last one a little bit taller, and then we'll firstly scale these 2 to a factor of 0.7 in both the front and the back. No, that actually doesn't work. We'll do the second or the last box. We'll bring that one back a bit. Oh, there's very little room to maneuver in the front. Is there more room to maneuver in the back? Also not too much. There does seem to be a significant step back here. You can see that the angle from which this photo is taken, like if we align this a little bit better, it seems that the step back is sufficient enough for the corners to all line up. So there needs to be some kind of setback for that to visually align. Yeah, there is. It's just not as much as we thought. Okay, then let's leave these 2 trunks in roughly the same space. Yeah, this does look a lot better. These lines, they don't match up quite, but there's some significance. Okay, then without further changing textures and handles and go into the detail, this is given as a rough representation. So we're going to go back to the isometric view. So we can see our trunks, yes, in relation to the 3D model. We'll go to street view, our second scene. We can now see the trunk in relation to the rest of the city. And so if we now maneuver our camera back through the streets, we might actually be able to position the camera in such an angle that we actually, without navigating directly into the buildings each time, we might actually be able to get a bit of a view, seeing all the trunks from street level, as if we were standing right there, and then look up. All right, let's add another street level scene. Rename that to street level 2. As a bit of an abbreviation. And then perhaps from the same corner, but the same idea, but from the opposite side. Because my geometry here is clashing with my ground surface, it's not looking That's fantastic. The other thing we can do is let's go to street level view 2 and let's turn the Google Tiles off so that all we're left with is the Google Street View photo. And then if we zoom in and match our building, so to say, we could almost get a street view photo that aligns with the trunk. Yeah, this is not exactly the kind of scale or position that you want your camera to be at for this effect. So that idea we're going to reject. That doesn't work that well. Then let's go back to the original street view. And instead of sticking to 5th Avenue, let's use E57 as our reference. Let's see how far back we can go in the 3D model while still maintaining this view. Yeah, this object here is actually not that great, but sort of avoiding that, we can look at it from this location. So let's add a third scene and call this street level 3. Street level 3. Then what we'll do is we'll turn now the Google Tiles off. We'll turn under the environment off. And then we'll turn our shadows off. Mr. TomTom can stay in the model. He can be quite helpful for skill reference. Let's get rid of the trunk. And then this is effectively our draft that we did earlier. So let's update the draft for now. Update that. Then what we'll do is we'll save the file. So this is, I titled this file LV. So I'm going to leave that as LV. Then we will go and save this again, but we'll save it as LV technical. And then we're going to turn the Google Tiles off. Actually, this is a little bit more cumbersome than what I want it to be. What I want to do is I want to delete all the assets apart from the geometry that we created, right? So I want to save our tower. And in the meshing model, if I hide this, I can of course still see the meshing model rough size. So I'm not going to delete that. I'm just going to take these trunks, make a group out of it and create a separate component, and I'll call it trunks. And then amongst the meshing model, I'll call another tag trunks. And then the trunks can be hidden, but the meshing model will stay. Yes, let's do that. Then this component, I'll right click it and say save out to device. The selected component has a non-default scale. Would you like to save it using this scale? Yes, please. Save that back to the desktop and then call that LV technical. So I'm saving over that file. The reason I'm doing that, of course I can't save it to that file because this is the file I'm currently working in. Excuse me. LV technical and then underscore trunk. Okay, that did work. Now, we're just going to observe the differences in the files. So this is what I wanted to show you. This is the LV original file where we have all the 3D information. This is the technical file that I'm getting rid of. It's 300 megabytes. And this is the technical trunk file only. And what I want to do is, I'm just going to open that file. You'll see that the 3D meshing, the Google tile, that environment is gone. But the thing that our file has still saved, which I don't want to save in this specific file, it has kept the 3D environment. It has kept the 360 environment. So the reason that this file is now so big is because some of those components are still in our model. So we've got our trunk component, which we don't want to duplicate, and we've got our environment. So I'm just going to go to model info, statistics, and purge. There's probably no problems. No. Then save that again. And then take a look at the file size of this. Okay, so that's 2.6 megabytes. That's a lot better than 300. So by getting rid of that environment, by getting rid of the 360 photo, which can be quite a large file, we can just save the model singular as a singular element, rather than have all that other data in that file as well. Then when we use something like layout, we don't always have to load in different assets. So for now, what we'll do is make this a little bit smaller. I'm going to drag the Louis Vuitton file, the SKP file, into layout, and that will be page 1. It'll take a second for it to find the last viewport. And that information stays on that first page. The second page that I'm going to create, that is only going to contain that technical model. So even though my layout file will be quite large because of these two files, once I start manipulating the technical information of the stack trunks and the meshing model, that first page effectively stays on its own. That overview of that section of Google Earth. And layout was very unhappy with my idea, probably because of the file size, or maybe because my computer is just not happy that I'm doing a screen recording and I'm loading a complex 3D file into my first slide. So we're going to try it again, but perhaps not with that specific file. So we're going to just start with that technical file. So let's load the technical file in. I'm going to make the technical file half the page. So let me just snap to the corners of this document. Then make it about half. And then I'm going to duplicate it. And then in this view, in this SketchUp model, I will turn perspective off. And I'm just going to zoom in to my parallel projection to have the kind of angle that I'd like to see. And without manipulating this viewport to look the same, I'm going to reduplicate this viewport. That saves me the camera movement. And then in this SketchUp model reference of this viewport, I'm going to go to tags and turn off the trunks, so that I'm left with the meshing model. The meshing model I can then express in millimeters or in meters. And I'll use the Alt key to perpendicularly offset this in sort of the same isometric view. Maybe draw that the other way around, right? So go this way. Yeah, that snaps much better. Then we'll do the same about that height. Yeah, that's going skew. That's probably not what we want. Okay, let's stick through that. And then what about this way? That falls just outside the drawing. So we have a 20 meter by 30 meter facade by a 75 meter high building in recognition of us using a geo-referenced accurate model. And then our trunks, let's set up the dimensions there really quickly. Our trunks have a height of 27 meters. This trunk I think was identical, or almost identical. Then a trunk of 6 meters. And then if we zoom in a little bit, a trunk of, maybe zoom in a little bit more, trunk of 6 meters. See, it's taking that sort of slanted dimension. So I do need to create a perpendicular straight down measurement. So that's 4. And then I hope that I'm right in saying that this trunk was also 4 meters in height. 4.17, yeah, so there was then the same height. And again, trying to perpendicular align this so that my measurements look meant to be. And then that last trunk was a little bit taller. Now the measurements are in meters, which is fine, but the expression of meters is making it a little bit difficult, especially here at the top, to read them out nicely. So I'm going to go to my dimension tray. I'm going to turn meters off for a moment, and then I'm going to say align on the outside, and then don't give me a precision of 0.2 decimals, but 0.1. And then let's leave that like that. So these two shapes and sizes are my very quick overview of the shapes and sizes of the trunks used to set out the scaffolding around this Louis Vuitton store on E57 and 5th Avenue. I hope you've enjoyed this demonstration. If you'd like to see me put actual scaffolding around the building using a SketchUp plugin, or if you'd like me to see the change of textures and render some elements here, let me know in the comments below if you've got any requests of that kind. If you have any other questions, or if there's a specific kind of video you'd like me to do in the future, then also reach out to me. And in the next month, you'll see some videos pop up as promised about a workflow using a handheld 3D scanner for getting good replicas of existing environments so that you can draw accurately and sketch up a new design. Thank you for your time. Have a wonderful day, and please like and subscribe. I hope to see you on the next one.